Hey students, this is lesson 13A, the method of constant differences. Basically, what we're going to learn is that if the relationship between two variables is linear, then you will notice that the change is constant in both variables. So let's just take a look at a couple examples here and see what we mean. So if I take this table right here and I graph it real quickly, so I'm graphing the points 1, 4, 2, 7, 3, 10, and so on, you'll notice right away that that's a linear relationship. So every time I go up over 1, I'm going 3 higher. And that's definitely a linear relationship. We could draw a straight line through those. Not a very straight line, but you know what I mean. And you will also notice that, check this out, these all go up by 1, which is pretty obvious. These all go up by 3. So from 4 to 7, from 7 to 10, and from 10 to 13, they're all 3. So basically, if you see a table and both variables go up by the same amount, it'll be a linear relationship. Now, imagine if this 2 and 3 weren't even here. And I just noticed that every time that these go up by 3, these go up by 9. If that happened again, like if I went 3 more than 4 would be 7, and 9 more than 13 is 22. So again, I'm going up by 3 here, and then up by 9 there, plus 9. If I graph those points, you'd also notice that they're linear. So what we're looking for are relationships where both the input and the output, or both the x and y, are going up a constant amount. So check this last one here, this table 4. You will notice there that the x's are all going up by 1. That's cool. That makes a linear relationship. But the outputs, the y values, this one goes up by 5, this one goes up by 6, and this one goes up by 7. Okay. I'm going to carefully graph those, so I'm going to make a graph so that you can see what's happening here. But according to what we've just said, I'm going to guess this is not going to be a linear relationship because the outputs aren't going up by the same amount like the other situation. So here's a nice graph I can put these points on from table 4. I'm going to put the point 210 on there. That's right there. And I'm going to put the point 315. That's right there. And I'm going to put the point 421. That's right. I'll have to move that one down a little. I can get it right exactly at 421. Okay, had some issues with my graph, but I got them graphed. Now, if you were to just glance at this, you'd say, oh, it looks linear. It looks like they're going up by the same amount. But check what happens when I put a line straight through these first two and extend it. You'll notice that that line does not go through the last 2 points, which means this is not a linear situation. So again, if it's linear, both the input and the output, or both the x and y, will be linear. Let's try one more problem on the next page. And let's look for one that might cause us problems like this one here. It looks like that the x's go up by all kinds of different amounts. That goes up by 2, that goes up by 1, this goes up by 4, and then the y's go up by a bunch of different numbers too. This goes up by 18, this goes down by something, I don't know. So what I'm going to suggest first is to order the numbers and then look for constant differences after they're ordered. So I'm going to remake that table and I'm going to put them in the right order. All right, so here it is. I just redid 2 down here, but I put them in the right order. And you'll notice now x is going up by 1 on all of them. And so I could, if I added one more, I would get 5. And y is going up by 9. 16 minus 7 is 9. 25 minus 16 is 9. 34 minus 25 is 9. So if I add 9, I get 43. And yes, that's the same point I have here. So we're going to say this is linear. And just to help you make a rule, if the x values go up by 1, like they do here, then whatever the y values go up, that's what you need to multiply by in your rule. So we need to multiply by 9. So we're going to multiply 9 by x. That's the slope. And if you multiply 0 by 9, 9 times 0 is 0. Just think about what you would have to add to get the number, the y value, and that would be a minus 2. So if I just subtract 2, I'll have a rule that works. You can check that on another one, like if I take 9 times 2, that's 18, and 18 minus 2 is 16, so that checks out. All right, so that's kind of what we're going to do. We're going to look and see if there's a constant difference in both variables, and if there is, we're going to assume it's linear, and then we're going to start working on how we write a linear rule. All right, that's it. I'll check back with you tomorrow or next time we meet.